Hello everyone, welcome to ChemBrain YouTube channel, your ultimate destination for learning chemistry. I am your host and your tutor, Andy Ago. I am here to ignite your passion for science and making learning chemistry a thrilling adventure. Please like and subscribe to my channel because today we are coming to delve into the world of fascinating organic compounds. What is organic compound? Organic compound is any chemical compound that contains carbon and hydrogen. Contains carbon and hydrogen. These carbons, these compounds are the fundamental to life and are present in all living organisms. However, not all carbon-containing compounds are considered organic. For example, carbonate, CO3, carbides and cyanides are exceptional. Why? Because they lack carbon hydrogen bonds. So in today's lesson, I'm going to talk about naming of alkanes. What is alkanes? Alkane is a type of hydrocarbon characterized by the single bond between carbon and carbon, and they are filled up with hydrogen or saturated with hydrogen. Defining alkane in that way means that methane violates this definition. Therefore, to add up, we say all alkane compounds should conform to the chemical formula CnH2n plus 2. Now that we have gotten the concept of alkane, let us try naming some unbranched alkanes. We are saying that trivial names of unbranched alkanes existed before organic chemistry became an organized branch of study. Some of these trivial names are still used today. Hence, a set of rules called the EOPAC rules are used to provide a unique, unambiguous names to these organic compounds. Same like us as we have our names, we have our first name and we have our surname. The same applies to naming of organic compounds like alkanes. They have their preface and they have their suffix. Their preface originates from the Latin or the Greek name, and the suffix usually ends with A, N, and E. That is A. Alright, so let's give a try of naming unbranched alkanes. So in naming of unbranched alkanes, the Greek name, that is the preface name, specifies the number of carbon present in that organic compound or in alkane. Therefore, for example, if we take CH4, how many carbons do we have? We have one carbon. Therefore, its preface is called met. If we have two carbons present, we have it. If we have three carbons, we say prop. If we have four carbons, we say but. Therefore, to complete the name of the organic compound, we add the suffix ane. So we say methane. Methane signifies that the organic compound conforms to the chemical formula CnH2n plus 2. If we say ethane, ethane means that the organic compound has two carbons and it is separated by a single bond and also conform to the chemical formula CnH2n plus 2. Now, this row continues and continues depending on the number of carbons present. To introduce you to branch alkanes or naming of branch alkanes, I'll firstly like to talk about alkyl groups. What are alkyl groups? So to say alkyl groups, they have one less hydrogen atom when we compare them to their corresponding alkane. Now let's take for example methane, which is an alkane compound. Methane has one carbon and four hydrogen. Assuming in a reaction form where methane loses one hydrogen, then methane becomes CH3. Now what we need to do is we need to drop the suffix ANE and add YL to the prefix. So we say methyl. So anytime an alkane compound loses one hydrogen in the course of reaction, then we also need to drop the suffix ane and add YL. So ethane becoming a substituent which belongs to the alkyl group, we say ethyl. If propane loses hydrogen, now propane belongs to the alkyl groups, of which we say propyl. Pause your video and please give a try for butane. Great. I know you had it. So we say butyl. So if hexane loses one hydrogen and become a substituent, we now call hexane as hexyl. The same thing applies to heptane. We say heptyl. So the list keep on going and going and going. Let's try naming some branched alkanes. In naming of branched alkanes, there are a lot of rules, a set of rules that needs to guide you to systematically name and write the EOPAC names of these organic compounds. And I will take my time to work you through some couples of examples. And I believe that by the end of these examples, you will have a firm ground in naming organic compounds, especially alkanes. So the first example is to name alkanes. All that we need to do is we have to identify the longest continuous chain of the carbon atom. Why? Because this longest continuous chain determines the parent name. So if we assume this to be the longest carbon chain, then this determines our parent name. Therefore, we need to count the number of carbons in the longest chain. We have 1, 2, 3, 4, 5, and 6. So if we have 6 carbon present, we say hexane. Hexane. Any other organic compound or any other form of compounds attached to the longest chain or the parent chain becomes a substituent. That is seen in example number 2. So any other compound which was attached to the parent chain now is determined as a substituent. Okay, so in rule number 2, now in naming of this longest chain, we need to make preferences. Therefore, in numbering of your longest chain or your parent chain, we need to number in a way that the substituent receives the lowest possible count. The rule number 2, in numbering the longest chain or the parent chain, we need to number in a way that the substituent receives the lowest possible count. So for example number 3, we could realize that the naming starts from 1, 2, 3, 4, 5, 6. Now, what is the position of the substituents on the parent chain is 2. If we take the reverse form, now we have 1, we have 2, we have 3, we have 4, we have 5, then 6. That is in the reverse form. So in the reverse form, the position of the substituent becomes 5, which is higher way than 2. Therefore, the preferred way of numbering the parent chain should be 1, 2, 3, 4, 5, and 6. So as the rule number 2. Good. Now, what we need also to do as the third rule I will give you is we need to designate the location of the substituent group. We need to indicate the position of the substituent group as part of its name. So let's give a trial of this one. We say 2-methyl hexane. 2-methyl hexane. Always the parent name comes the last, and the substituent, then the number of position or the position of the substituent. So now the substituent is at position number 2, so we say 2. Now what is the substituent? The substituent has only one carbon, so we say methyl. Then the parent name is now hexane. Before I move on to the other examples, I would like to draw your attention to very pertinent stuff about organic chemistry. Anytime we see a line in naming, we should always bear in mind that there are 2 points, and this point is carbon. So every line in organic compounds or naming signifies that it is joined by 2 carbon. It is joined by 2 carbon. So when we look at this example, we have carbon and we have carbon. However, the carbon here is only 1 because this carbon is part of the parent chain, so cannot be included as a substituent. So we have only 1 carbon. Good. Let's move to example number 4. So the first rule is we need to number the parent chain. We need to choose our longest chain of the carbon. We need to choose our longest continuous chain of the carbon atoms. So let's give a trial. We have 1, we have 2. Let's consider this as the longest carbon chain. So we have 1, 2, 3, 4, 5, and 6. If we go the other way around, we have 1, 2, 3, 4, 5, and 6. So we can also label it this way: 3, 4, 5, and 6. Or we can go this way: 5, 1, 2, 3, 4. Good. 5 and 6. Now, depending on the direction we want to move. So one student can decide, okay, let's go this way, in this direction gives me 6. In this direction gives me 6. So now here comes another rule. When 2 or more substituents are present, give each substituent a number corresponding to its location on the longest chain. And we have also learned that in numbering, we should number it in a way that the substituent receives the lowest possible count. The lowest possible count is the preferred way of numbering the parent chain. So now if we number in this way, it means we have 2 substituents, which is this substituent, then this substituent. Now to verify, we need to say this substituent is position number 2 and position number 4. So we have 2 plus 4, which gives us 6. Okay, if we choose the longest parent chain as 1, 2, 3, 4, 5, and 6, then our substituent becomes this part, then this part. So we have our substituent as position number 2 and at position number 4. Great. So it means we have 6 for each other. So when we choose our parent chain as this, we have 6. If we go in this direction, we have 6. Great. So I choose the longest parent chain in the horizontal direction. So this is 4. Now, What if another student says, why not we starting from here in the reverse direction? So let's see. We have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So now let's see the positions of the substituent and see what the number of the substituent gives, or the results of the substituent. So in this direction, we have substituent at position number 4 and substituent at position number 5. So in addition, we have 9, which is far away than 6. Therefore, the preferred way of numbering should be in this direction. I believe you get the concept now. Great. So let's give a trial in naming this. Let me put here 3, 4, then 6. Okay, so now we have our substituent at position number 2, our substituent at position number 4. All right, now in naming the substituent, we also need to name them in alphabetical order. We need to name the substituents in alphabetical order. All right, so this substituent is called, we have how many carbon? We have only 1 carbon present. The carbon here joins to the parent chain, so cannot be counted as a substituent. So we have only 1 carbon, so we say methyl. Now when we come to this substituent, we have 2 carbons present, so we say ethyl. Very good. So we have our ethyl, we have our methyl as a substituent. Now ethyl and methyl in alphabetical order, E comes before M, so we have to say 4 ethyl, 2 methyl, then the parent name hexane. Very good. Let's try example number 5. So in example number 5 is a case when 2 substituents are present on the same carbon atom. Then we should use that number twice. If we have 2 substituents which are present on the same carbon atom, then we should use that number twice. Let's give an example of the trial. Okay, so the first thing we need to do is we need to identify our longest continuous carbon chain. Our longest continuous chain of the carbon atoms. Okay, so if we choose this direction as our parent chain, then how many carbons do we have? We have 1, 2, 3, 4, 5, 6. So our parent name becomes hexane. Good. Now, how do we number our parent chain? Do we start from this end? Do we start from this part to this end, or do we start from this part to this end? It depends on the way which gives the lowest possible count of the substituent. Great. So now if we count from 1, let me erase, then we can see properly. Okay, good. So if we start counting from 1, carbon 1, carbon position 2, carbon at position 3, carbon at position 4, carbon at position 5, then carbon at position 6, meaning that we have this substituent at position number 3. If we choose the numbering in the reverse direction, we have 1, 2, 3, 4. Therefore, the substituent receives position number 4, which is far more than 3. So the preferred way of numbering should be 1, 2, 3, 4, 5, 6. Now, 6 carbons present in the longest chain. So we say hexane. Now let's try to identify our substituent. We have 2 substituents which is bonded to the same position. Let's see how many carbon does this substituent has. It has 1 carbon. This part of carbon is joined to the parent chain, so cannot be counted as a substituent. So we have only 1 carbon present, so we say methyl. Let's see this substituent. We have 2 carbons present, so we say ethyl. In naming it, try to name it alphabetically, the substituent alphabetically. So we have EAT, E, and MET, M. So it means we have 3 ethyl, 3 methyl hexane. Very good. Let's try example number 6. So example number 6 comes in this way. When we have 2 or more substituents and these substituents are identical, indicate this by the use of prefixes like di, like tri, tetra, and so on. So let's continue to choose our longest continuous carbon chain. So I choose this as my longest continuous chain. And if I number, I have 1, I have 2, 3, and I have 4. If I choose the reverse direction, I'll have the same number of position of the substituent. So 2 plus 3 is 5. If I go the reverse, I have 1, 2, 3. So both substituents are identical have identical positions on the parent chain. Now, what substituent is this? This substituent has 1 carbon, so we say methyl. What substituent is this? This substituent has 1 carbon, so we say methyl. So this is identical substituent at different position. So in a case where we have identical substituents, then we need to choose the prefix di, tri, tetra, penta, and so on. So in naming this one, we say butane. That is the parent chain. Butane. Now, how many substituents do we have? We have 2 substituents. So we have 2, 3 dimethyl butane. 2, 3 dimethyl butane. Very good. Let's see example number 7. Let's see example number 7. Okay, so in example number 7, it comes in this way. When we have 2 chains of equal length and they compete for selection as the parent chain, choose the chain with the greater number of substituents. When we have 2 chains of equal length competing for selection as a parent chain, then choose the chain with the greater number of substituents. So let's try this example. We have this parent chain as 1, 2, 3, 4, 5, 6, 7. Great. How many substituents do we have? We have this substituent, methyl. We have 1, 2, 3 carbons here. So we have this substituent called the propyl. We have this substituent called the methyl and methyl. So we have 4 substituents present when we choose our parent chain this way. Another student will say, why not choosing the numbering the parent chain in this way? So we have 1, 2, 3, 4. Now here becomes 5. This becomes 6. Then this becomes 7. We all have the same number of carbon chain. So now in this direction, we have this as our substituent. We have the whole of this as our substituent. Then we have the whole of this as our substituent. So we have only 3 substituents. But when we choose in the other direction, we had 4 substituents. So in this case, which one is the preferred one? We need to choose the one that has greater number of substituents. We need to choose the one that has greater number of substituents. So in that case, the preferred way of numbering is 1, 2, 3, 4, 5, 6, 7. Great. So we say 2, 3, 5, trimethyl, 4, propyl, heptane. If we choose numbering in the reverse direction, we will have a highest possible count of the substituent, which is not preferred. I hope you can try example number 8. So example number 8, we have this as our parent chain. So we need to now identify the positions of the substituents. This substituent is at position number 2, this substituent is at position number 3, and this substituent is at position number 5. So we say 2, 3, 5, trimethyl hexane, not 2, 4, 5, trimethyl hexane. Okay, this brings us to the end of this video. I would like you to take this as an assignment. Please like and subscribe to my channel. On the next video, I will give an answer to the try example. Thank you for watching.